Hey guys, welcome back to part 3 of the Arduino incubator series. So in the previous video we kind of went a little bit too deep about the basics of the transistors. A lot of people have been asking about the part 3 of the series, and here it is. In this video I am going to go a bit fast and not going to go into that much detail compared to the previous video. So in this video we're going to just complete our circuit. We're going to add in fans, actually only one more fan. We're going to add in the LCD display, possibly the motor driver, and buzzer, and whatever we can get it in the video, we will try to get it in. And thanks for everybody who liked the video and was asking for more. I really appreciate it, and glad you liked it. So let's get started. So as you might have noticed, the circuit has changed a little bit because the previous circuit was like a year ago. So I had to recreate this based on the previous video. Here it is. So it looks similar. So what we did on the previous video was we added a continuous fan. We tried to control it with a transistor, and we also added a diode to prevent the backflow or EMF of the fan. Now we're going to add in another fan which is going to control the humidity. Now this fan is going to be kind of similar. Actually it's going to be almost the same, so we're just going to take in these things. So we're just going to copy this connector, paste it here, press space to rotate it. We're going to name this humidity fan. I hope you can see it. And we're gonna take in this transistor and put it here. This resistor, copy it, paste it, put it here. Copy the diode, put it here, I guess. Yes, the negative goes into the positive and positive goes into the negative. And just kind of connect it with the main source. So let's connect it to the digital pin first, taking the input of the base to D3 of our digital pin. So these pins actually doesn't matter, we can change it in the software, and as we go along we are going to change it. So connect the emitter to the ground, take the ground from here, put it here, and connect the emitter of the thing to the negative of the humidity fan. Take the positive and connect it to the positive of the power supply. Sorry if I'm going a bit fast, so if you don't understand what I'm doing or why I'm doing this, just watch the previous video. Now here just connect up the diode, and I think we will be good to go. So now what we're going to add is a buzzer which is going to signal us if something is really going wrong. So any buzzer is fine. They are very simple, so you just apply voltage and they generate noise. The one I'm going to choose is just going to be a 2-pin one, and it's going to beep when I give it voltage basically. So connect this in here. Now notice we are giving all of these appliances transistors because the components that are going to take more than 50 milliamps or possibly more than 50 milliamps or 20 milliamps, we give a transistor so that it can take its power from the main source instead of the Arduino, because it's going to burn it. So copy this here, paste it here, copy this here, paste it here, and I think we are going to connect this to D5. Connect this to the 12 volt. Here we go. So we are done with this. Let's see, what else do we need to add? Yes, we would like some extra lights to illuminate the box or the incubator while we're looking at it. So we're gonna add an LED strip. I'm just gonna go in here and choose an LED here. So the symbol for an LED is this one. It's just a diode with arrows coming out of it. So we're gonna connect this here, add another transistor. So we want to make this transistor a bit different because it's going to take quite a bit of current Well, not that much. I'm pretty sure this can handle it. Actually, we can change it later when we finish the schematic. And let's connect the D6 to this. So be careful about having too many appliances, because the Arduino Nano actually has a limited number of digital pins, and you're going to run into problems if you use them all. I'm already adding in too many things, so I'm thinking I might have to lower the appliances at some point. Anyway, connecting the ground here. So connect this here to the negative. Yes. Nope. Connects to the negative of this. So don't worry about the LED's orientation. We can just change it in the PCB if you get it wrong, okay? Just make sure that the ground goes to the emitter and the other ground goes here, so that we can complete the circuit. And we're gonna connect this to the 12 volt, because normally these kind of appliances take 12 volt, and that's the industry standard. We've added our LED strip, and let's see, we've added a buzzer, we've added a continuous fan, a humidity fan. Now let's leave out the temperature part for now, and let's because that's going to be a bit tricky, we're going to add a triac and a MOSFET, so we're going to have a pretty efficient heating system for this. So we're going to come in here, we're going to add our sensors now. Let's see, what kind of sensors do we have? We had a DHT22, which is going to get the... Actually, I have come across another temperature sensor, which is called the DS18B something. I'm not sure it's going to turn up. Yep, here it is. Digital thermometer. Let's go with users contributed. Yep, this should work. So what we're gonna do is we're gonna just add in we're just gonna add in a 3-pin connector. So we come in here, we add a 1x3, so add that in here, name this DS18B temp sensor. So the way you're gonna name these pins is gonna be a bit different. I forgot to mention it in my old video. If you just double click on this and just type in the values, it's gonna give you an error later on. So what you need to do is just click on the edit symbol, and then you're gonna put in your name in this pin name. So don't put it in the pin number, because this is what the software uses to correlate different components together or connect them together. So pin name, we're gonna give this the name of ground. The other one should be, let's just name this data out. Capital O, and we're gonna name this VCC. Okay, we're good. Now let's just connect this up. Here we go. The data out, so I'm pretty sure it's a 2-wire interface. So I'm thinking it's gonna take a digital pin. No, actually there isn't any circuitry available in that package. So I think we're gonna go with the analog pin. So we're gonna go right around here and connect this to the A0. Let's connect this to the A0 pin. So this sensor is going to give us an analog value. Basically, it's just a thermistor, and the way they work is it's just a material which changes its resistance based on the outside temperature, and we measure that resistance in the analog pin. So, and let's connect up the VCC here. Now let's connect the VCC of of our Arduino to the flag so that all of this will be interconnected. So notice we have added grounds, and I think I've explained it in the previous video, but this is what helps interconnect all these things, and when we do the wiring later on, you will see that it's very convenient. Anyway, we've added a sensor. So in order to have a pretty reliable incubator, you need to have well, actually I like to have two temperature sensors, and so this is going to be our temperature and a humidity sensor. So the main temperature sensor is going to be the other one, and this is just going to work as a let's see, yes, oh, that's a pretty nice graphic right there. So this is gonna serve as a correction point, or a comparator, maybe, as it's called. It's gonna compare these two values. So if one of them fails, the other one should be there to protect our circuit, and we could get a warning that our temperature sensor has failed, because these things really do fail, and when these fail, everything is gone. Let's connect our ground here and connect this, and let's just shut up. Then go into data. So this data is actually this data is digital because it has an IC inside. So that works for us and gives us a one wire interface. Let's connect this to D7. Connect this to VCC. Okay, so our temperature, humidity sensors are done. Now let's add a few more things. Let's see what else we need. Yes, we need a LCD display. So it's called liquid crystal display. We could add an OLED display, which I actually recommend, but I think that would it might not be available in certain countries, so I'm just gonna go with liquid crystal here. They work quite well, so you're gonna have a great time. Yes, so we can create our own connector for that. So what we're gonna do is going to choose a 1x4 connector. Because this LCD is gonna operate with a I2C backpack, this helps us with the wires, so that we will use less wires in this configuration. And let's name this SCL, SDA, VCC, and GND. Now this sensor, this display uses a protocol called I2C, and it's a pretty interesting protocol, and I'm pretty sure if you look around for it, you're gonna enjoy the read. And yeah, if you want me to talk about it, we can talk about this, but it's pretty basic. You don't need to go deep into this. It just minimizes the wiring and helps us connect more devices into a 2-pin configuration. So we go here, we connect the ground up to ground, we connect the VCC to VCC, and now here the thing is that the SCL and SDA pins, the A5 is the SDL of the Arduino Nano, and the SDA is A4. So these might be, I might be wrong about these two pins, but we could just simply we could just flip these two wires and it would work for us, so don't worry about that. And we also need a few buttons to serve as an interface for our incubator. So I'm just gonna go in here and select just a few buttons. Yes, I think these should work. So we've added 1, 2, 3. Okay, more buttons don't hurt. So this is gonna take a lot of our pins, but there is a way to wire them all up with a single pin, with a single analog pin. So one leg of each of these buttons are going to be interconnected. Let's connect the pin 1 to pin 1, and let's connect the other pin 1 to pin 1. Okay, we're good. And then what we're going to do is that we are going to common this to the ground. We're going to have a ground here, and we are just going to connect a resistor of about 100k. I think that's a bit overkill, but I think 100k should be enough. So we're pulling this buttons down, which means it's going to give us a steady value instead of floating around. If you want to look into this topic, this particular trick is called pulling down a button or something, pulling down and up for different purposes. Anyway, connect this to pin 1 of this, and I think the other thing we're going to use is, okay, the next thing we're going to do is we're going to take a few resistors, 1, 2, 3, 4, and we are going to give them different values. 10k, 5k, do we have a 5k? Let's go with 3k, 3k, 2k, and 1k, and then just connect these and just connect this other leg of the button, of each of the button, to these resistors separately. What you're going to do is take the number 2 pin and connect it here, this here, this here, and this here. And then what you're going to do is that you are going to connect all of this, common all of this to 5 volts. You're going to common all of this to 5 volts. So I'm going to take a 5-volt flag here, and I'm going to connect one of these, the other end of the resistor, to VCC. So we connected all of these other ends of the resistors together and connected them to the VCC. And now what we're going to do is we're going to take this part, so one leg of the resistor is going to connect to the ground, and we're going to take the leg before that, so it's going to be near the switch. We're going to take this here, and we are going to take a branch from this. We're going to connect this to the A1. So the way this works is very interesting. So what we've done is we have commoned all of these, and we have pulled them low with a 100k. So what's gonna happen, this is gonna serve as a debouncing mechanism. It's not gonna give us a lot of debouncing, but it's good enough. So what's gonna happen here is that as this switch gets pressed, this resistor is going to be activated, so the current is going to go from here to here to here to the analog pin, and this is going to give us a specific value. But then when this is turned off and this one is turned on, this one is going to give us a much higher current, and it's gonna go into the same analog pin. So that's how this whole thing works. I hope there's nothing very confusing about this. We're just doing this to save our pins, and with that I think we are good to go. Let's see, what else do we need to add? I think for now this is good. So let's just write here what we need. We're going to draw up a triangle here. So here I've written a few sentences. These are going to be things that we're going to do in the next video. We're going to add a motor driver for the incubator to turn the eggs, and we're actually going to common all of these connectors. So that's going to be fun. So we will have to do something about all of this. And we're gonna add things that we've forgotten in here, so some extra features like safety and whatnot, an emergency button, maybe anything, whatever you guys think of, you can comment down below and I will integrate that in the next video. So stay tuned for the next video. I hope you enjoyed this, and see you in the next video.